Lesson 9-7, solving equations with radicals. So let's review for a moment. If I have the square root of 100, that equals 10. If I have the square root of 169, that equals 13. Now, if I have the square root of some unknown quantity and that equals 10, well, this unknown quantity can only be 100. And the way we would solve that is we would square both sides. If we square both sides, the square root of x squared, these square roots cancel each other out, and I'm left with x, and x would equal 100. If I had that the square root of x is equal to 13, again, I'll square both sides, and I will get that x is equal to 169. Sometimes we have a situation where it's not simply an x in the radical and we don't just have a radical equal to a number, and that's when we get into our equations with radicals. So we're going to start with pretty basic ones and then we'll move forward from there. So if I have the square root of n is equal to 9 and I want to find out what n equals, I'll square both sides, and n is equal to 81. If I have the square root of x plus 5 is equal to 14, for example, I'll subtract 5 from both sides. Then I'll know that the square root of x is equal to 9. Then I square it and find out that x is equal to 81. So our first step will be to isolate the radical. So I'll have radical whatever is equal to everything else. My second step is then to square both sides. Excuse me. And then my third step is to solve any resulting equation if necessary. So let's try a few more examples. If I have the square root of m divided by 10 is equal to 10, I will square both sides, and I will get that m divided by 10 is equal to 100. Then I have another equation to solve. I have to get rid of this 10 in the denominator, so I'll multiply both sides by 10, resulting in m is equal to 1,000. I could have addition or subtraction underneath the radical. V minus 4 is equal to 3. I square both sides. Now when you square something underneath a radical, you're not foiling it because this square and this radical cancel out and you're just left with whatever is underneath the radical. So v minus 4 is equal to 9. Add 4 to both sides and you get that v is equal to 13. Sometimes we have more things occurring in the equation. For example, I could have negative 8 plus a radical 5a minus 5 is equal to negative 3. So you can see I am adding to the radical and I have an expression underneath the radical. I need to get this radical alone first, so I need to isolate the radical. So I'm going to add 8 to both sides. And that gives me the square root of 5a minus 5 is equal to 5. Now I square both sides, and I get 5a minus 5 is equal to 25. Add 5 to both sides, and I get that 5a is equal to 30, and then dividing by 5 gives me a equal to 6. Sometimes we end up with a situation where we end up with radicals on both sides of the equation. When that happens, it looks like this. And we have to do one extra step at the end. So our first step on this is going to be to square both sides. Then we'll solve. And actually, I was wrong. We don't have an extra step on this. Sorry about that. So I'm going to square both sides. And I'm going to have 3n is equal to 4n minus 1. I will subtract 4n from both sides. And I get negative n is equal to negative 1, so n is equal to 1. Another example, the square root of 3n plus 12 is equal to the square root of n plus 8. I'll square both sides. And I get 3n plus 12 is equal to n plus 8. Subtract n from both sides. 2n plus 12 is equal to 8. Subtract 12 from both sides. And 2n is equal to negative 4. Divide by 2, and you get that n is equal to negative 2. Now this next example is when you end up with an extra step, and that's if we have variables on both sides of the equation. Okay, and that might look something like this. If I have p is equal to the square root of 2 minus p, when I square both sides, I end up with p squared is equal to 2 minus p. And now I'm going to set it into a quadratic equation. So I'm going to square both sides. Well, actually, the first step is still going to have to be isolate the variable. If that's, sorry, isolate the radical. Then square both sides. And since I have a variable squared, I have a quadratic. So I need to set equal to 0. So I'm going to subtract this 2 and add the p from both sides. And I will get p squared plus p minus 2 is equal to 0. And then I will solve by factoring. So I have p plus 2, p minus 1 is equal to 0. P plus 2 equals 0. P minus 1 equals 0. P equals negative 2 or p equals positive 1. Now here's where it gets that extra step. You need to check both solutions. To see if they work. You could have what's called extraneous solutions. And an extraneous solution is a solution that you achieve by solving, but that when you plug it back in, it's no longer true. So when I check the solutions, I'm going to plug in negative 2, and I get negative 2 is equal to the square root of 2 minus negative 2. So I get negative 2 is equal to the square root of 4. Or I have 1 is equal to the square root of 2 minus 1. 1 is equal to the square root of 1. This is our extraneous solution, because while it is true that negative 2 squared does equal 4, we're calling this extraneous because we're only looking for the principal roots. So our solution is p equals 1. Let's try another. Sometimes you don't have a single variable on one side. You could have a variable expression. And so when we square both sides, we have to remember our pattern. And so I'll get b squared minus b times 6 times 2, so that's 12b plus 36 is equal to 18 minus 3b. I'm going to subtract 18 from both sides and add 3b. And I will get b squared is equal, minus 9b plus 18 is equal to 0. Now I need to factor this to solve it. And I'm looking for factors of positive 18 that will give me a negative 9. That's going to be negative 6 and negative 3, because 6 times 3 gives me 18, and when I add them together I get 9. So b minus 6 equals 0, b minus 3 equals 0, so b equals 6, and b equals 3. Now I'm going to go back in and check these. 6 minus 6 is equal to the square root of 18 minus 3 times 6. So that 0 is equal to the square root of 18 minus 18. 0 is equal to the square root of 0. This is true. b minus 3 is equal to the square root of 18 minus 3 times 3. 3 minus 6. Oops. I plugged in the 3 in the wrong place. Let me fix that. Three minus 6. So I have negative 3 is equal to the square root of 9. And this is my extraneous solution, so I'm looking for just this positive 6.